From the Centre for Public Christianity, you are listening to Life and Faith. I'm John Dixon.
And I'm Natasha Moore.
For thousands of years, many thousands of years, humans have looked up at the stars and asked questions about the universe and about themselves. The night sky has caused wonder, worship, existential angst, and of course, astronomy.
So what do we lose if we never see the stars? Because of light pollution from cities, it's estimated that 80% of Europe and North America no longer experiences real darkness. For example, one morning in 1994 in Los Angeles, there was an earthquake before dawn which cut power to most of the city. The Griffith Observatory received call after call from residents who were freaked out by what they called the strange sky. What they were seeing was stars.
I totally get that. Years ago, in the times when I drove around the country singing in a band, we were out past Daly River in the Northern Territory, and at nighttime just kept on turning the headlights on and off as you drive along the road. And then we decided to stop and get out of the car, turn everything off. And we were overwhelmed, we city slickers, with there's a lot of stars up there. It's not like what you see here in Sydney. Then we did see a brown snake and we hopped straight back in the car and
came back to Earth.
Yes, our wonder at the universe turned into fear very, very quickly.
Astronomers report that most students actually arriving at university come from the suburbs and they have that experience. They've never really seen the stars with the naked eye. So there's this disconnect between those initial feelings of wonder and curiosity that humans have had, looking at the sky, feeling small, and our study now of the universe.
Today, as we acknowledge Australia's National Science Week, we're speaking with a stargazer of sorts. Dr. Luke Barnes works at the Sydney Institute for Astronomy, connected with the University of Sydney. And he counts cosmology, galaxy formation, mathematics, and the universe as some of his areas of expertise. And actually, a few years ago, he sat in my historical Jesus course at the University of Sydney. So he's a man of eclectic intellectual pursuits.
Luke, welcome to the program.
Thanks for having me.
We're going to start off with a few of the really important questions.
Look at the stars. The great kings of the past look down on us from those stars.
Really?
Yes.
Are the stars actually great lion kings of the past looking down on us?
Yes, we've discovered that it's official now.
Wow, I really would have thought I'd hear that reported more in the media.
Yeah, well, we tried. We put out this long film about it. It was animated. People thought it was fictional.
Oh, shame. These things backfire. Pluto, not a planet. Were you sad about that? Did you see that coming?
That happened as I was starting my PhD, and I gave a sort of popular level talk. And afterwards, a parent came up to me with their child and sort of looked at me and went, it was her favourite planet. Like it was my personal... I'm a PhD student who's like at the bottom of the pile, but apparently it was all of our fault.
You ruined her dream.
Yeah. These things happen. It was nothing to do with me.
Okay, how plausible do you think this whole living on Mars idea is?
That's a very good question. I don't know. It's very, very barren up there, obviously. So the ideas are things like, let's just drop an atomic bomb at the North Pole and then try and live at the South Pole. And when that's an idea for a planet, things aren't in great shape.
Yeah.
But obviously, you've got a lot of work to do in terms of water and soil and anything to make an ecosystem up there. But, harder things have been done.
Have they?
Maybe, actually off the top of my head, I don't know.
I can't think of any. But, okay, last one. Do you personally still look up at the stars a lot?
Oh, yeah, absolutely. Especially because I grew up in the country. I grew up in country New South Wales, sort of halfway between Sydney and Brisbane, where there's a fantastic night sky. And I'm now in the city where it's sort of red tinged and you can't quite see anything. So if I ever get outside of the city lights, you definitely look up as much as possible. So I was away with a bunch of blokes I know. We were camping and I have no camping equipment. So in return for that, one of them providing a tent, I brought along the biggest telescope I could borrow from some other friends of mine. And so we had a great evening of just there's Saturn, there's Jupiter, there's the moon. And
as a scientific researcher, when you look up at the stars, you probably see a bunch of stuff that, I don't see. So what do you see that other people don't see?
it's funny. People think that I'm going to know what the constellations are, but actually, how the ancient Greeks drew lines between the stars isn't really what I study. So the things that really interest me is the Milky Way across the night sky. If you get a nice dark sight, you'll see the Milky Way. And in particular, there's dark patches in the Milky Way that are sort of dust clouds. And that's the gas still forming, still moving around, absorbing light, all of that sort of stuff. It's kind of interesting. We see the pattern of brightness across the sky. The ancient Aborigines saw the darkness and made this sort of an emu you can see if you look at the dark patches in the Milky Way. But so when I'm looking up, I'm looking at all the stuff that's not stars, because that's, for me, the interesting stuff, because that's the stuff that's still moving and churning and making interesting things.
Luke, how did you end up in the Sydney Institute for Astronomy? And can you give us a peek behind the curtain of this illustrious institution? What's it like to work there?
So the sort of day-to-day work of an astronomer is very varied between the different people in the department, depending on what their interests are and whether they're more on the theory side of things. Those people will be, looking at equations, looking at computer code to solve those equations, trying to work out whether their model lines up with reality, versus the observers who might be in the office, or they might be off at the telescope. They might be in the office but asleep because they've been up all night because they've been at the telescope.
Where do you sit on that spectrum? Are you the guy that likes looking at the squiggly numbers on the page, or do you prefer the big, beautiful things out there in the real world?
Oh, I'm a theorist, definitely a theorist. No one lets me anywhere near the telescopes, and neither should they. So yeah, just coming from that physics background, it's always been about the equations for me when you're good at maths.
Now, I'm surprised you didn't pick me up and say you're contrasting maths with the real world.
Well, I mean, if you meet mathematicians, they're not always got their head in the real world. They don't particularly care about, famously unencumbered by the real world. They're all about the elegance in the equations.
You seem like quite a normal guy, making eye contact, all kinds of things.
So the question I most often get is, which one of the Big Bang Theory people are you?
Which one
Please
are
don't
you?
watch that show. Well, not really. Raj is the astrophysicist, but we're not all as socially inept as those four particular individuals. Although,
thankfully,
it's not entirely wide of the mark for some people.
So if you're studying literally the universe, there are a lot of things to find out. Can you tell us about some things that you've been learning recently that are new to you?
So my research at the moment is focused on how galaxies form. So what we do is we start off with what we think the universe started off like, which is basically smooth distribution of matter. There are small lumps and bumps here and there, but they're very small. And then if you've got a lump of matter, gravity will make the rich richer. Basically, it'll make a lump attract more things to make a bigger lump. And you let that go for a very long time, and hopefully out the other end comes galaxies. So we have computer simulations that try to do this. You take that problem, you break it down for a computer, sort of a couple of thousand linked computers, and you throw them at the problem and see if what comes out at the end of the day looks like a galaxy.
How much of what there is to know do we know? Or do we not even know what we don't know?
Well, here's a basic thing about the universe. So from gravity, from Einstein's ideas about how the universe works, we can sort of tell what it's made of by the way that it's expanding, and so we can do a bit of a census of the stuff in the universe. So there's the stuff we think is out there in the universe, and then there's the stuff that we have seen on Earth in labs, like all the ordinary matter we're made out of. And it turns out that the ordinary stuff accounts for about 5% of all the stuff that's out there in the universe. So the rest is about 25% is dark matter, and the rest is something called dark energy. And the only reason you would call anything dark matter and dark energy is if you have no idea what it is, right? So, we have some idea of what it does, but in terms of how much do we know on that scale, the answer is we're scoring about 5% in our test of what's the universe made of.
Does that fill you with hope, or is it frustrating, or does this inspire wonder?
What you really want is a good open problem. So there's a quote from a physicist called Ed Hines, who says that the reason we do physics is because the universe is like the biggest crossword puzzle you've ever seen. We want to know that there's empty squares, but we also want to know that it's not so difficult that we're never going to get the answer. So the fact that there's major unknowns and glaring unknowns, tells us that there's unsolved problems. The universe is not like a crossword puzzle that we've done and there's nothing else to do. The worry is if you don't know what it is, you don't entirely know what you need to do to work out what it is. Maybe it's going to take 500 years of solid astronomy to work out what this stuff is. But along the way, the universe has always proven to give us some very wonderful problems to solve. So physics will continue.
You're fairly relaxed about being both a Christian and a professional scientist. But do you ever have moments of disconnect between the science and your Christian convictions, or even contradiction?
I think there are some things that when someone asks you, why do you believe this, that, and the other, it's difficult to explain. And I think part of that is because there's this idea that religious faith is a way of knowing something, and it's a way where you just ignore the evidence and just believe something you want to believe. And if people have that idea, then there's an entire side of the stuff that I think about the world which seems to some people just to be sort of stapled on, like I've got the scientific mind which follows the evidence, but then I just wanted to believe all of this rubbish, so I just stapled it onto my worldview. If once you lose that idea of faith, then you can sort of start to look at what are the foundations of what you believe and its broader implications.
So you don't think faith is just a shot in the dark? You don't think faith is believing stuff contrary to the evidence?
There's an old joke that I like that illustrates this. Any joke that's an illustration isn't going to be funny, but stay on board for this. So there's a tightrope walker. There's a tightrope stretched across Niagara Falls, and there's a tightrope walker who is wowing the crowds. He's gone one side to the other. He's done it without the pole. He's done it carrying a wheelbarrow. He's put a sack of potatoes in the wheelbarrow. The crowd's going bananas, and he's revving up the crowd, saying, "All right, who thinks I could do it with a person in the wheelbarrow?" And the crowd cheers. He goes, "Louder! Who thinks I could do it with a person in the wheelbarrow? Louder! All right, can I get a volunteer?" Silence. Mm-hmm. So that's the way I think of it. There's, on a very basic level, that belief is saying, "Yeah, I reckon you could do it with a person in the wheelbarrow," and faith is getting in the wheelbarrow. So that's my basic illustration of what's going on there. On a more perhaps intellectual level, it's the difference between what you think is true and what's called decision theory. If you think it's 99% sure there's not a car coming, you can't 99% cross the road. You either step out or you don't. So that is the gap. You can go with the evidence or against the evidence, but at certain times in life, you just have to step out.
You're listening to Life and Faith from the Centre for Public Christianity. We're speaking with Dr. Luke Barnes, co-author of a book called A Fortunate Universe, Life in a Finely Tuned Cosmos. So why the title, A Fortunate Universe?
So I wrote the book with he was my honours supervisor and is now my boss, Geraint Lewis. He's an atheist, so we wrote most of it together, just about the science, and then at the end there's a sort of a conversation about what we think all this means. The title, A Fortunate Universe, was kind of a nicely ambiguous to what we think is going on. So he thinks of fortunate in sense of lucky, that just the right universe turned up to have the sort of properties that we need to survive, that any sort of life we can imagine needs to survive. Whereas I'm thinking of fortunate in terms of, there's a plan. It's maybe blessed is a bit too religious, but that sort of idea. So it's sort of ambiguous between those two things. But there's something interesting about the way our universe is set up, which doesn't look like an accident. It looks fortunate in one sense or another.
Can you tell us a bit more about those conditions that make us call it lucky or fortunate?
So from a physics point of view, there are sort of glaring things in our equations we'd love to explain, but at the moment we can't. Things like, is an electron, if you remember your atom, the electron goes around the outside. That's a number that we can measure, but we can't calculate, and we'd love to be able to calculate it because that would be amazing. So with a whole set of these numbers, we think, okay, why are they what they are? Why do the basic particles have these masses? Why do they interact so strongly? And if you change these numbers, in a lot of cases, a very small change makes a huge difference to the universe, and in particular, totally erases the kind of complexity that life needs. So, for example, it doesn't take too much just messing around with the basic stuff of atoms before you just erase the periodic table. There's no chemicals. The only thing that's stable is hydrogen, which can bind to itself to make a hydrogen molecule, and that's the whole of chemistry there. You could do it on one sheet of paper rather than a whole textbook. And at that point, you've lost so much of the complexity that life relies on. It looks like that sort of universe is just going to have hydrogen atoms that bounce around and nothing else. It won't do anything interesting like us. So this is called the fine-tuning of the universe for life.
Can you tell us a bit more about that conversation at the end of the book that you have with your co-author? What kinds of things do you go into there, and is there a conclusion?
Well, I don't want to give away the ending, do I? We reached that point where we both agree, okay, there are these basic properties of the universe, and if you slightly changed some of them, it would be a disaster for life as we know it. So we seem to have something we need to explain, and then we just go through a couple of the options. Maybe there's some ultimate physical theory we need to find which will totally set all of these numbers. It'll just tell us bang, 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 why the electron's this mass, why that force is that strong. It'll just lay down everything. We actually both disagree with that option as a solution, because then it would just look like, okay, there's still a coincidence there between the ultimate laws of nature and whatever abstract mathematical symmetry or whatever they obey is, and life. There's still a coincidence there, even if it's not in the form of this number if it were different. So then we talk about the multiverse. One of the ideas is the universe is fortunate in Geraint's sense. It's like winning the lottery. You just got lucky because the reason why someone got lucky is because there were lots of different tickets bought. So if applying that to the universe means there's lots of other universes out there with lots of different properties.
And we just happen to live in the one.
We just happen to be the fortunate universe.
Is that idea of a multiverse based on any evidence, or is it really just a way of avoiding the spooky implications that it happened once and this is what we got?
There are cases for a multiverse which, at least at face value, don't aim at solving this particular problem, the fine-tuning problem, and then make the case that they've solved this along the way. So isn't this great? But it is a worry. I mean, we're supposed to be doing science, we're supposed to be doing physics, we're supposed to be grounded in evidence that we can see, and we've got this theory where, by definition, the basic element of the theory is that there are all these other universes out there, and almost by definition, we'll never observe any of those other universes, or even if we do, we might observe like one, and we need a bazillion of them to provide enough lottery tickets that we can explain why a universe with the conditions for life is out there at all. So in terms of, is this science, that's a awkward question for the multiverse, because it seems like a way the universe could be, but it's very different from the usual way of doing things.
What are our other options?
So we discussed that one, and then I talk through, if, from my point of view, believing that there is a good God, how that sort of fits into that picture. There's all these possibilities, and even if you could get the ultimate laws of nature and write them down on a blackboard, there'd still be a whole heap of other ways the universe could have been. And so if you are a naturalist and you just have to kind of swallow the blackboard as is, that seems like an awfully big thing to swallow, especially if it looks fine-tuned. But if you think that there's a creator who explains why there's anything at all, and that creator is a good creator, suddenly you've got a reason for a universe with the right properties for moral agents like us being created and being allowed to sort of play out in a way that gives creatures moral freedom.
The orderliness of the heavens convinced the ancients, whether caveman or Aristotle, that there was a rational mind behind the universe. But does this new scientific knowledge, and therefore explanation of the orderliness, make that universal human instinct redundant?
I don't think so. I think there's a caricature of how the history of science has gone, which goes a bit like this. We used to believe that the gods created thunder when they were angry, and then we worked out about the laws of electromagnetism, and now we don't need God at all. And so God is kind of out of a job. The problem with that is, historically it's nonsense, because just about all the makers of the scientific revolution were all believers in God. The reason they thought there were laws there to discover in the first place, rational laws, is that they thought there was a rational mind behind the universe to start with. But even then, I like to think it's probably far too mundane an example, but I spend a lot of time coding computers. I think of creating a computer game, and I think through what I want to do and of all the ways you could code it. I select one that does what I want it to do. I write the code. Think of a case where I build the computer and I run the code, and then there's people inside. If it's good enough, there'll be characters inside this computer game who could look around and start to work out how their world works. If they work out part of how I've made their world, at no point does that put me out of a job. We've described the way the world works. We haven't in any way explained why it's there and why it's orderly in the first place.
It's almost like it's not the gaps in our knowledge that allow us to believe in God. It's the fact that we know this stuff. It's the comprehensibility of the universe.
Yeah. If you think there's a creator who created, order, and then that's why the universe is the way it is, then finding more order is not at any point threatening to the creator. If you spot some larger, grander pattern in the mosaic of tiles that some tiler is putting up, right? If you spot that bigger pattern, you've not in any way insulted the tiler.
But are you assuming God first and then saying the orderliness of the universe fits with that? Or for you, does it work the other way? Or are they in some way recursive?
The way I really think about it is if I was a naturalist and I really thought through the consequences of what if nature was all that there was, and when some physicist, perhaps in the future, puts some equation up on the board, that will be the ultimate principle of reality and all further questions will be out of bounds. I think there's an awful lot about our world which should make that person uncomfortable. The fact that there's rational laws at all. I mean, you can have natural things that don't obey any sort of orderly laws, orderly principles. You can have ones that do obey orderly principles, but no finite agent could ever work them out. You can write down those sorts of equations. The fact that we've got both, we've got an orderly universe, one that, there's laws that we can discover. It's laws that permit for the existence of life as we know it, and it creates a beautiful universe. These are all things that are out of bounds, in principle, unexplainable if you're a naturalist. And I think that is far too big a price to pay relative to a picture where you put an ultimate reality, an ultimate creator, and goodness at the very bottom of the reality.
We in our culture are very concerned with kind of finding our place in the world, and we mean various things by that. We think about which communities we identify with and what our personalities are like and whatever else. As an astronomer and a Christian, what thoughts do you have about the place of humanity in the universe?
I think it's very good to be reminded of how small we are at times. I think that's very important. It's something there. I mean, the psalmist in Psalm 8 thought that was a good idea as well. What is humankind that you are mindful of them? Our place in the whole sort of scheme of things, we're very small in a huge universe, which gives us a sense of the infinity that we're lost in and the power that's out there. I think there are natural things in our world that kind of point in the direction of their creator. It's sometimes thought that if God created us and we were the point of the universe, then we'd be much bigger or something. It would be human-sized. I don't see any reason for that at all. There's a wonderful quote from C.S. Lewis. What do you want? A universe which is cozy. People often ask, how can the universe be, fine-tuned for life or, created by God if we make up such a tiny fraction, some ridiculously small percentage? Well, what percentage would you like? Would you like 50%? Would you like us all slashed in, cheek by jowl, unable to move? 30, 25, 1? How much room do you want? So I think our place in the universe as being small is just sort of a reminder of who we are. But again, the most complex thing we've ever discovered in the universe is sitting inside our head, thinking about the universe. It's the human brain. So we don't measure significance with size. There's something interesting there that we're small and yet we're the only ones who can understand how small we are.
So far as we know.
So far as we know. That's another question, I guess.
From the Centre for Public Christianity, you've been listening to Life and Faith with John Dixon and Natasha Moore. We've been speaking to Dr. Luke Barnes from the Sydney Institute for Astronomy for National Science Week. Luke has co-written a book that's available in bookstores and online. It's called A Fortunate Universe: Life in a Finely Tuned Cosmos.
Listen to this interview again on our website, publicchristianity.org, or you can find us on Apple Podcasts or wherever you get your podcasts. Just type Life and Faith in the search box and hit subscribe. While you're there, do us a favour and leave us a rating or review. It helps other people discover our show.
Next week, an Australian mathematician, an Oxford professor, and the former Archbishop of Canterbury on the beauty of numbers, patterns, and the divine.